Hey everybody, in this series we're going to make a turn-based battle system. This system's really designed for our Pizza Legends project that's been going on. If you've been following along with that, awesome, this is the next step. If you haven't, it's totally okay. You can take these concepts and run with them and apply them to whatever project you have going on, just making tweaks where necessary. There's a link in the description below that has all the code for this, so if you want to grab that and code along with me here, feel free. Here's a quick intro of our pizza battle system. So let's take a look at the high-level architecture and some of the components that we're going to be building out as we create this battle scene. This is a glance of the end result that we're going for. See, we got some characters here in the middle of the screen. The map background can change out based on which overworld map we're on, and we've got an area for text down here. So starting at the bottom here, we have our friend, the text message component. It's going to use the exact same functionality that we created for the overworld, but we're going to be able to repurpose it for the battle. This text area here is going to print out text when things happen in the battle, like I use this attack, this thing happened. That's all going to go right here. The next component is the submission menu. Its one job is to receive the action that a combatant wants to use. If the current combatant is player controlled, a menu like this will pop up and the player can choose whatever move they want to use. This thing is click and keyboard friendly. But if the current combatant is AI controlled, then the component will automatically make a decision on what move to use. This is where the enemy AI decision-making code can live too. The combatant component represents state of a single character. There are only ever two active combatants on screen at a time, one for the player, like you see here, and one for the enemy. But both player and enemy teams are made up of multiple combatants. In addition to holding state, these classes will also have methods on them that determine how much damage they take in certain situations, like if an incoming attack is something they're really sensitive to or strong against. They'll also handle special behaviors given their status. We'll talk more about the statuses in a second here. Zooming in on that combatant scoreboard piece for a second, here are the different pieces of state that our UI will be showing. For one, every pizza is going to have a name, and that'll be printed right here. Each pizza also has a type that's represented by an icon. We'll get to the types in a second. We'll be keeping track of current HP and max HP, so we can calculate a percentage to fill this bar, and same with XP. We have the pizza's level over here, which will increase as you grow the XP bar and level up. That's like a general indicator of strength. And down here, if the pizza currently has a status, we'll print the status name in this little box. The battle will keep track of two different teams, the player team and the enemy team, and towards the top of the screen, we'll print the status of each pizza in that team. The full lit up icon means the pizza is healthy and good. The little arrow underneath it means it's the current one that we see on the screen. And if the pizza's dead, we'll show a dead version of the icon. Here's a little visualization of how the data is structured in the class. See, we have two teams, player and enemy. The teams have a little bit of identity in that they have a name and then a skin associated to the person that we see on screen. Each combatant that we have in the class is associated to a team, so either player or enemy. Here are the four pizza types in the game. We've got veggie, spicy, fungi, and chill. Chill is stuff like ranch dressing and pineapple, by the way. Each type will have a strength and a weakness, and we'll cover the details of that when we write the code to configure each one. And of course, you can add your own. The two types of statuses that we're going to implement in this video series are saucy and clumsy. Saucy is what we consider a positive status, where after every move you do, you recover a little bit of HP, so that's a good thing. Clumsy is what we consider a negative status, and when you're clumsy, you're basically going to have a 33% chance of failing to do whatever move you tried to do. So you'll select a move. If you're clumsy, we'll roll the dice. Your move may end up doing nothing. Now we're going to lay out a whole framework of event hooks that you can use to create your own statuses as well. These two just kind of demonstrate how to get you started, and I'll leave more advice for that as we go. So here's a really high-level view of how the whole system works. For one, all of this is nested in an overworld event called Battle. So while this is going on, the overworld is just like patiently waiting for this battle to complete. It will create a new battle class and then await the on-complete callback to be fired. The battle is going to be broken out into a few different little subcomponents and subsystems, the biggest one being the turn cycle. where the turn cycle is going to take in an action, which move the player wants to use, and then it's going to display all the events of that action. So an action will define, I want you to show this text message, and then I want you to take whoever I use the move on and subtract 10 from their HP. There's going to be some more math in there as well. After we've shown all the events to the player and we've gotten through them all, we ask the question, is any team dead? If not, we switch whose turn it is, and then we start the whole process over. But if we do have a winner, we can fire this onComplete callback, reporting back some information on like who won the battle and what happened during the battle, and then the overworld can proceed like normal. The next good bit of the video series is really only going to focus on this part here, having nothing to do with the overworld, but it's just good to know how it all fits together. So in this first video, we're just going to focus on getting the scene set up and ready to go. And so we're just going to create the components that we need for that. Now our project has a lot of stuff in it already, and so I'm going to start introducing some folder structure so that it gets less crazy. So come up here and create a new directory. We'll call it battle. This is where all the battle scripts are going to go. So in here, I'm going to create 4 new JavaScript files. The first is going to be battle.js. The next is going to be combatant.js. Then we're going to have team.js, and these line up with the components that we talked about earlier in the video. And finally, we're going to have submission menu.js. I think that's all of them. And it's worth noting that if you have not been following along with the Pizza Legends project, that's totally cool. You can do these same steps into your new project or whatever you're working in. There's just going to be a few maybe things you need to add along the way that we've already done in the series, and I'll call those out as we go. So let's hop over to battle.js, that first file we created, and make a new class called battle. It's going to get a constructor. It's going to get our usual component stuff too. So we'll do a create element method and a init method. Oops. And then we'll add a few more as we go here. Init is going to take a container, and basically, again, like we've seen before, this component is going to create some DOM and then inject it somewhere, and that container is where it's going to get injected. We'll also be initializing some subcomponents of the battle system in here, so this is going to get pretty long. Let's create the actual battle scene here, the whole container of the whole thing. So that's going to be this.element is document.createElement, a new div. This div is going to have a class on it, so we'll say classlist.add battle, and now we'll give it some inner HTML. As a reminder, here's the scene that we're going to be building out in this video. Everything that you see here is that battle div that we just created. Inside it are going to be a bunch of absolutely positioned elements. So this hero, this container here, these things up here, it's all going to be position absolute because they have really kind of specific positions that we want them in. Absolute's going to make it really straightforward. Now in our HTML here, we're going to bring in one div that has an image inside it. And this is for the battle hero. So we have a BEM style battle hero class on it, and then an image inside there with alt text. Notice that the skin here is using some string templating. That's because in theory, we'd be able to swap out the appearance of the hero and not always be tied to this exact image. And we'll have the same thing for the enemy. It's the same exact structure, same concept. This will swap out and be dynamic as we battle different characters in the game. The difference in class name here, battle hero and battle enemy, is going to be how we're going to differentiate the positions of these two different characters on screen. And just to note real quick, you'll notice that we're using image tags here. While the overworld section of this project was very canvas heavy, the battles are going to be very DOM element heavy. And that's really just because I want to show you 2 different ways to achieve this kind of thing. If you prefer the canvas way, you could certainly refactor a lot of this battle stuff to be canvas. There are many different ways to do this and many trade-offs for each way that you do. So pick something that works for you. It's okay if you need to change this. Let's go ahead and run this code now. And so we'll say, after we init, we'll do that this.createElement to get that div going. And then we'll go ahead and inject it into our container. So that's gonna be container.append child this.element. Now we're gonna need some serious CSS here, a lot of it throughout the next few videos here. And so what I'm gonna do is follow a convention where for every JavaScript component file, we're gonna have an equivalent CSS file. So in here, we're gonna create a new style file called battle.css. And I'll just create the other ones we need also. So we'll have combatant.css, team.css, that's gonna be that row of pizza indicators, submission menu.css. Now we're good to go. I'm gonna clean up the screen here and then open up index.html. Let's include all of this stuff on the actual page. Right before we init, I'm going to make a new section of scripts called battle. And in here, we'll get our 4 scripts that we created. Again, the order doesn't really matter because of the pattern that we're using for initializing whenever we need to. So I'll just kind of do them in whatever order. Cool, and let's do the same thing for our CSS files. So we'll come up here, battle CSS, grab one of these. Hopping over to our first CSS file, battle CSS, I'm going to bring in some styles here and we'll talk through them. So first, like we said, the battle container is really just going to hug the corners of the screen and overlay on top of everything. So it itself is position absolute and it's got all 4 corners here so that it just, stretches to cover the entire thing. Then we're going to bring in our map background image. In the future, we'll actually be swapping this out based on whatever overworld map that we're on right now, so that if you're in the kitchen, the battle should look like a kitchen. Right now, we're just defaulting to the street battle. Should note that all these assets are linked below. There's code download links where you can get all these images and stuff, so feel free to grab that. We're going to have background size cover to stretch properly across our container here. And then, of course, anything that we see inside the battle should be image rendering pixelated. Now, I expect this to look like a train wreck at first, and we'll see why in a second. But let's go ahead and just focus on getting this in the browser on screen, and then we can make it better from there. I'm going to hop over to our overworld code, and we're going to start the game with a cutscene. So I'll bring this line back in, and we're going to make a new event type. Here's the ones we had in the previous Pizza Legends video. I'll just make a new type called battle. In the future, we can include like which battle we want to do. Say it's a boss or a certain enemy that has a certain configuration. We'll cover all that soon. For now, we're just going to default to like just a battle. Now we need to handle this type of overworld event. So we'll go to our overworld event, collapse everything we've got so far, make a new one called battle. And again, that's also going to take a resolve. We won't mess with this too much right now. Again, we're just trying to get it on screen, but the high level idea is that eventually when the battle's over, we're going to resolve this event, including some information about like who won the battle, that kind of thing. So we'll create a new instance of our battle class. Say battle is going to be a new battle, and it's going to take in one of these onComplete functions. And for now, we can just like resolve the event. Again, we'll probably beef this up later as we come back to it. As soon as it's there, we can initialize it. So we'll run the code battle.init and then passing in the element that we want to inject the battle into. And for anybody out there that's joining us that hasn't been following along with the Pizza Legends series, really you just need to fire this block of code and then probably take this resolver out because it won't exist for you. And then you'll be right up to speed with us. We just need to create a new battle instance and then inject it to the DOM. So now when our game starts, we can load up the browser and see that it looks... it's working. Definitely a little bit of a train wreck. We're loading in a whole style sheet that we need to go ahead and crop with CSS. We'll explore that technique in a second. And then there's a lot of other stuff we got to get on screen and scale right. Let's pop over to battle.css and add some styles here. So bringing in some styles for that battle hero and battle enemy container. For one, again, they're both going to be position absolute. All the characters in the battle are going to be scaled up by 2. Everything otherwise would be a little too zoomed out for the layout that we're going for. So basically our pixel size is going to double only when we're in the battles here. We're going to create a cropping box for our character to only have 1 frame appear. And so we'll say that's 32 by 32 because that's the way the sprite is designed. And then anything outside of that will be overflow hidden. So it'll get cropped off. And then on these containers, we can also put a background image to layer that shadow underneath. It's the same shadow that we use in the overworld canvas drawings. Down here, we have a little convenience rule for pointer events none on the actual image tags inside the hero and enemy containers. For us developing this, it's going to enable some easier inspecting. And then finally, we're going to bring in the positioning of our characters. So that battle hero container is going to start from the bottom and be towards the left side of the screen. The image inside it needs to be nudged a little bit because remember, we're showing an entire sprite sheet. The hero is facing upwards, so we want to nudge that sprite sheet to show the correct frame. I have a full video about this technique that I'll link in a card or something on YouTube here. But in short, this line is just going to make it look like the hero's facing upwards. And then our battle enemy is going to hang out in the top right part of the screen. Let's see what this looks like. Now it's starting to look like something. The hero's here facing upwards, enemies here facing downwards. Let's move on to our combatant class now, which is going to get the scoreboards and the pizzas on screen. It's really going to bring the layout to life. Back in the code, I'll open up our empty combatant.js and make a class for it. Constructor, init, create element, all the stuff we usually see. Our constructor in this case is going to take in a configuration object for this combatant. We'll talk more about that in a second. And then a reference to the battle class because they need to interact a little bit. So we'll get the simple one out of the way. This .battle is going to be whatever battle is. So config is going to be all of the information about this combatant. And so it's going to be stuff like what's their HP, what's their experience points, if they have HP, how much HP can they go up to, something like that. What's their name, what kind of attacks can they do? We'll call those actions. There's going to be a lot of stuff in here. And so because of that, we're going to actually spread anything that's in the configuration object onto the class. And when I say spread, what I really mean is we're going to iterate through all the keys that come in the configuration object and then add those as values to the class. Sort of anything that's in here will automatically be accepted. There are certainly trade-offs to that. If you're looking for a more explicit system where you're only looking for certain keys, maybe something that's like strongly typed, you may want to change this. But for us, in simplicity's sake, we're just going to go ahead and iterate through all of the config keys. So that's going to look like this. Object.keys, our config for each key. And we've seen a pattern like this before. I think this key is going to be equal to whatever config key is. So if we received like HP 10, after this we'd be able to say this.hp and that would have a value of 10. We're going to get to this init and create element part soon, but these are going to be pretty gnarly, pretty complicated because the combatant has a lot going on in it. So before we do that, I think it's going to be more clear if we head over to battle and start creating the combatant classes, and then we can sort of get them on screen after that. So the battle is going to have a key object store of all the combatants that are present. So for example, like the player's pizza 1 will be a new combatant, and then here we can pass in our configuration, and then also a reference to the battle, like we were ready for. So like we said, what if it's HP 50, out of 50? We'll just start at the beginning, XP 0, level 1. As XP increases and we overcome the threshold of what it means to hit level 2, then we'll increment this level here and then reset the XP back to 0. The last thing we need to know is what status the character has. Most of the time that's going to be null. That means there's no status, and that's good. If there is a status present, it's going to look like this. It's going to be an object with a type like clumsy, and then some information about the status. So for example, expires on or expires in 3. That's like 3 turns. So as the turn cycle goes, we'll get into that later, this will downtick and then eventually expire, and then we can delete the status. For now, let's just say null. Now let's talk about our pizza universe for a second here. This combatant is an instance of a certain type of pizza. So to bring the Pokemon comparison back, like Pokemon, there's different, Pikachu or whatever. You could have a bunch of different Pikachus, a bunch of different instances of those. So we're going to follow that same model here, where there's like one model of pizza, and then this combatant is an instance of that type of pizza. So you could have a lineup full of the same pizzas, or you could have, different ones. We need some kind of data store on where those pizza prototypes are defined. There's a Pokédex. This is like a pizza dex, if you will. So we're going to move on to that now. Now this is going to open up a new section of our project where we're going to start storing content. And content, we actually kind of have a good example of that already in the overworld map file, if you've been following along, where in this file we have this data store of configuration for each map. We're going to add that same kind of thing for pizzas and for a lot of other battle stuff, but we're going to go ahead and do that in a different dedicated place. Okay, with this file active, I'm going to go ahead and create a new directory called content. It'll sit right next to battle there. And in there, I'm going to make a new file called pizzas.js. We need to make sure this is included on the page, and we're going to do so pretty early up here. Now this pizzas file will be a place for us to sort of flesh out all of the, universe data of our game. The first thing I'm going to bring in is an object called pizza types. And this is just going to be a simple sort of way to have consistent naming of all of our types. So normal, spicy, veggie, fungi, and chill, each of these are just strings. And so anywhere else in the code base where we want to refer to a certain type, we just say pizza types dot spicy, and then, even our editor will kind of know what we're talking about. It'll help us auto-complete it. This is really just for accuracy and convenience. Now I'm going to bring in the early days of our pizza decks, which is basically just a giant object with a sub-object for each pizza in our universe here. So it's window.pizzas, it's an object. For example, there are 3 here. They all have a unique ID, like S001, V001. That S is for the type, spicy. So going key by key here. Each pizza is going to have a name. So this is like our equivalent of Pikachu. Slice Samurai, it's a spicy type. Again, referencing our map up here. It has a source, and that source is the skin of the pizza, what it looks like on screen. Again, in the code download links below, there's all these images that you can look through and use. Each one is also going to have an icon that appears on screen, and so we need to know which image to use for that icon. That's also defined on the pizza here. This being its own key rather than being computed by the type is kind of nice, because maybe for certain pizzas you want to use like a fancier icon, like a shiny pizza or something. That way it doesn't have to be married to the type for which image you want to show. Down here we have 2 more examples. Our first veggie pizza and then a fungi pizza. Same concepts, just different types and different skins. With all of these defined now and on the page, when we are starting our battle and we're providing the configuration for a combatant, we can start by dynamically pulling all of the keys and values from one of those pizza types. So say this pizza, player 1, is going to be pizzas S001. I'm going to use the spread operator here. That's going to go ahead and just copy over all of the values, just like this. It's going to be like almost as if I copy and pasted this and put it right here. From here, we can come in and layer in the stateful bits of our pizza, like the HP, max HP, all the stuff that will change. The last thing we need to add to our pizza configuration here is which team this combatant belongs to. And so to do that, we're just going to make a new property called team. And there's going to be 2 possible values in this game. Say we were making a game that had maybe not just one-on-one kind of setup, but maybe multiple teams that could attack each other. You could change it to work like that. But for us, it's just going to be 2 different possibilities, either player or enemy. Next, I'm going to bring in the configuration for 2 more pizzas, 2 more combatants. So enemy 1 and enemy 2. Basically, this battle is going to be set up initially so that the enemy team has 2 pizzas and the player only has 1 pizza in their lineup. This enemy is of the veggie type, and this one is the fungi type, and I'll go ahead and update my syntax here so it all matches. Now it's worth noting this battle is sort of hard-coded right now, where every battle is going to start with the same configuration. As we go here, we're going to make this dynamic so that all the player pizzas come in through a loop, like what's the player's designated lineup, and then all the enemy pizzas come in from which battle am I playing right now. Now that all of our pizza data is flowing in, I think the combatant class is going to be a little bit more clear. So let's pop back over to combatant.js. And we'll start working on the template for getting the actual DOM of each pizza, each combatant on the screen. For the create element method here, I'm going to start bringing in some code, and we'll talk through it line by line. For one, we're going to do our usual pattern of creating a new element. This one's going to be called this.hud element though, because we're going to end up with 2 different types of elements. So this.element doesn't quite work for us here. It's a new div. It's going to have the same class name as combatant, just like we've seen before. Something that's a little bit new is that we're going to start utilizing data attributes for some styling. So here we're going to add a data attribute for which combatant this is. So that'll be the ID back in battle. You see that, player 1, for example, enemy 1, that's an example of IDs. We're also going to include which team this combatant belongs to. That's going to enable us to style this combatant to sit on the screen, either on like the bottom left side along with the hero or the top right side with the enemy. Next comes the actual template for our pizza combatant, and I apologize, this is a lot. You can feel free to pause and kind of type all this out. I didn't want to have to do it on camera. That would slow our pace down here. But let's talk through it line by line. First, we're going to have a paragraph that has the combatant name on it. So that's just the name of the pizza. Then we're going to have a different paragraph that has the level in it. It's starting empty, but we're going to dynamically fill it because we may be updating it as the character gains XP and maybe that level up changes. Next, we're going to include a little bit of an avatar inside our HUD element. We're actually not even going to use this in the battle scene, so maybe thinking like, why are you talking about this right now then? This same component is also going to be able to be used outside of a battle in the overworld, but we want to display the status of your pizzas in the top left corner. We'll see that in a little bit, but basically because that component can be reused, we want to include a little bit of an avatar of which pizza is on there. It's like a variation of this component kind of. We don't really need that in battle because we're going to see the dedicated pizza itself later on here, but I just wanted to call that out. This will make more sense later. Next, we have the combatant type, which is one of those icons that's defined in the pizza's data. And we have two SVGs for the fill of the HP bar and the XP bar. These are rectangles that use certain colors that look right, and they're going to be positioned just right on the screen to basically fill up the life bar outline. And we'll talk about that in a second when we start adding CSS for all of this. The widths here start empty, but we're going to dynamically update them on the fly to be a fraction of our current HP over our max HP. Same concept for XP, exact same thing, just slightly different colors and positioning. And then finally, we have our combatant status. It's going to start empty. As the battle goes on, though, we may gain or lose status, so we'll be dynamically updating this element to have the text of whatever status we have. Let's move on to the CSS for all this DOM now. And this is going to be probably the most CSS heavy part of the entire course, the entire series. So I hope you like writing CSS. Here it comes. The first thing we're going to do is bring in the basic styles for our combatant HUD. And so that's going to be a plate that has the correct height and width assigned to it based on the design of the plate, and position absolute, because we'll be putting them in different parts of the screen. Combatants that are marked as the player team will have these top and left values, and then enemy team will have these top and right values. Next is going to be the styles for that character cropping bit that we talked about. And so this is just another container. It's absolute within our HUD plate. It's got some positioning on it and a certain size to crop out only part of the pizza. And again, anything outside of it will be hidden. That's how we achieve the cropping effect. The pizza itself is positioned inside there. Again, though, for battles, we're not even going to show that thing. And so I'm just going to say display none on it, only when it's in battle context. If you want to skip writing this out for now, you can. It will come in handy later, but it's your call for now. Next is our name and type styles. So we'll park right here and talk through them. The name is going to sit position absolute from the container just off the top left there. It's going to have some white space no wrap in case it's a really long name that wants to wrap. Themed background colors, just white text. Again, a note, we mentioned it in a previous video, but because our viewport of the game is really small and then we're scaling it up, some of the CSS values might seem really small. Like 5 pixels is normally super unacceptable, way too small for accessibility reasons. It's just tiny. But remember, that gets scaled up here, so it won't actually appear at 5 pixels. It'll be much more readable. Basic padding and margin reset on that paragraph. The type icon is pretty straightforward. It's just position absolute with a little bit of nudging happening. The height and width defined to be the exact size of the image. Next, we need a little invisible container for our life bars to go. And so combatant life container, it's going to be position absolute, again, within the plate, positioned at just the right spot, and carved out to be the same size as what's defined by the image. Next comes our XP container and our level. You're definitely starting to notice the pattern of all these things are really just absolutely positioned inside our plate element. XP container is the exact same concept as the life bar was. It's absolute. These values are carved out to match the asset exactly. Level is going to be a number that's just kind of floating off to the side there. It's, again, just absolute. It's got a size on it, some nudging, the size of the box, and then just some flexbox centering code to make sure that number sits right in the middle of the box. I feel like that just looks a little bit nicer. Background and border colors probably should be using a CSS variable here, but I'm kind of breaking the rules here. Feel free to update this to look like whatever you want it to look like. And then again, just margin resetting. We are almost through the CSS forest here. Our last bit for the combatant plate is the status. Again, that's just absolute. It's got a certain font size. It's nudged to be in the bottom kind of right side of the screen. We're using left here though. You could use either one. Padding, a nice background color for contrast so you can actually read it over the background of the map. Color and margin reset. Again, feel free to tweak all this to look like whatever you want. These were just sort of to my taste when I was quickly trying to lay this out. And here's a cool, interesting bit here. The combatant status will have a data attribute called status on it. I think we left that out of the template so far, but we'll add it back in. Where based on the string name of the status, we can style the badge a little bit differently. So maybe we want saucy to appear with this red color, If it's the clumsy status, we may have a different kind of purpley color. You can kind of theme the statuses however you want this way. Okay, mad props for copying down all that CSS. It will pay off in the future. So let's get this stuff on screen now. The first thing we need to do is finish up something in our combatant.js file. We're creating the element, or at least we're set up to create the element, but we're not calling it yet. So let's do that now. That's the same pattern that we usually see. So we're going to call this .createElement, and then we're going to go ahead and inject into a container the element that we created. And the one we created is this .hud element. So now when we initialize the battle itself, we can go ahead and iterate through all these combatants and then run init on each one, passing in the battle container, which is the battles element. So let's go down to our init here. We'll say object.keys, this.combatants. For each key, we're going to pull out that combatant that we're talking about based on the key. We're going to go ahead and tack on an ID to the combatant, and that can be the key, just like we talked about before. And then let's go ahead and run that init method. So that will inject it to the DOM. The container we want to inject to is our battle element. So we're in battle now, that'll be this.element. So now that all this initialization has happened, we can go ahead and see this on screen. When we start the battle, we see the HUDs appear, but they're super tiny. That's because just like we did with the characters here, we need to make sure that we're also scaling these elements up by 2. So let's go ahead and add that in. So back towards the top of combatant.css, I'm going to add in some rules here that should only affect the combatant when we're in battle context. Remember, this component gets used in a few different places, so we need to make sure that we only do that here. For one, we're going to scale up so it's not tiny. That way it'll match the pixel size of the characters. And now we only have one active combatant per team at a time, but they're all in the DOM. And so we want to make sure that we hide the ones that aren't currently active. So we'll select each combatant that's data active false and turn its opacity to 0. And then we'll do the opposite for combatant data active true. That'll be opacity 1. In the future, we can layer in some animations so that they animate from opacity 0 to 1 when they come in and come out. We have not yet put these data active attributes on. We'll do that in a second when we talk about updating the DOM of each combatant, but just know that this is set up and ready for us to go. Now when I load up the browser, I can see the scoreboards appear at right size, and already the layout is starting to fill out. It's great that these are appearing on the screen now, but they're very blank and boring, so let's go ahead and start filling them in with the stateful values. Back in combatant.js here, we're putting a bunch of elements on the screen, and that's good, but right now there's no way for them to update, where if the health changes or the status changes, we don't have any code that's doing that. So let's go ahead and start a new method called update, and it's going to bring in or accept an object called changes. And if that's not here, we can just default to an empty object. And this method is what's going to fill in all the stateful values in our DOM. So the first thing we're going to do in update is actually allow the values on the class to be changed. And so, for example, if we receive a new HP of 100, we want to go ahead and set this.hp to 100. And so again, just like we did in the constructor above, we're going to utilize a dynamic loop to do that. And so it's going to look like this. For any key in the changes object that comes in, we're going to go ahead and set this key, whatever the key is, to the value. So changes key. So now values can be changed, but we need to actually see those changes in the DOM. I think one of the most basic, straightforward things we could do first, just to get it out of the way, is this level, which starts empty. Anytime the update method runs, which it's going to run after every change is made, we want to go ahead and make sure that that DOM node has the correct value in it. And so what we can say is this.hud element query select the combatant level, class name, like that, and its inner text is going to be equal to this.level. We need to run this method for the first time. So down in our init method, we'll say this.update to populate the initial values. Now when the battle starts and those things initialize, we'll see our level appears in the box. Now a way more interesting thing that we can show is the fill of our current HP and XP. And so again, we need to come up with some kind of percentage so we know how far to fill these bars up. Back in our combatant class here, we're going to create a new getter on the class, and we're going to do a few of these, but the first one is going to be HP percent. Basically, the percent is going to be whatever this.hp is divided by this.max HP. That's going to give us a decimal, but we want a nice clean whole number that's the percent, so we'll multiply it by 100. Now, in the event that this percent is negative, like HP is below 0, we want to go ahead and just floor the bottom at 0. And so we're going to return a value, but if the percent is less than 0 or equal to 0, we just want to return 0 and not like a negative number. So we'll say if it's greater than 0, return whatever it is, but if not, return 0. So again, if it's negative, we'll just get 0 back. Now we want to use this HP percent as the percentage of the fill or the width of these rectangles inside our combatant life container SVG. So this value here we want to swap in to be whatever the percent is that comes back from our HP percent getter. HP is going to be updating a lot, of course, and so we have two elements that we need to update here. One is like the base color and one is the little highlight on the fill just to make the art look nicer. Because we're going to be doing this so often, I'm going to go ahead and save a reference to those two paths. So I'm going to say this.hpfills is going to be equal to a query selector all inside our HUD element looking just for the rectangles directly under combatant life container. This way, every time we run update, we don't need to keep redoing this over and over and over again. And now in update, we can go ahead and iterate through those. So hpfills.forEach rect, we'll say rect.style.width is going to be this.hp%, but we actually want to include the percent sign on it, which we're currently not getting that back. So we're going to wrap this bit in a string like this, and then interpolate in the number and bake in a percent sign. I like that HP% doesn't return the percent sign by default because we may be using it for comparisons later on, and so it's fine to just bake in the percent here. Now when we boot up the battle, our fills should be filled in to 100%, so this is looking nice, and this is happening because our characters are starting the game with HP 50 out of 50. So let's just see what happens if we play with those numbers. We'll go to battle.js. In here, I'll tune the player down to like 30 out of 50. And then both of these enemies here, I'll say 20 and 25. And now when I reload in the browser, you can see that the percentages update accordingly. Now let's quickly get the same concept going for the XP fill too. I'll go back to the code, and in addition to XP that we're currently getting, we'll also give in a max XP. That's going to be like the goal that we're trying to get to. Do that for all the characters here. Eventually this will dynamically come from some kind of level map that again is defined in our RPG content, but for now we can just leave it like this. And let's say that we're like 75% of the way there. Moving over to combatant.js, just like we have HP%, we can pretty much do the exact same thing for XP, but we can simplify it because XP will never be negative, so we can just say return this much. Updating these to be XP and max XP in the name. We want to go ahead and cache our rectangle fills in the same way. So XP fills, almost the same, but it's going to be XP container to pull these rectangles, which are positioned differently and then have a different color on them. And so let's fill this part in too. In update, we can go ahead and do the same idea, but for the XP fills. So for each XP fill rectangle, the width is going to be XP%. When I reload, you can see our percentages show up in the bottom bar too. Now there technically is a little bit of a bug here, and that bug is that currently both of the scoreboards for the enemy combatants are appearing on screen. And so if I look at the DOM here, I can see there's 3 total. This one and this one are still present, and so enemy 2 is actually layering right on top of enemy 1. The next thing we need to do is introduce some kind of idea of which combatant on each team is active right now. And then we're going to be able to use that to only show the information of the active one per team. As soon as we know that, then we can start drawing pizzas to the screen too. In the constructor of battle.js, right underneath our combatants here, we can also keep track of the state of which combatant is currently active per team. And so that's going to look like this, where we're going to have a new class variable called active combatants. It's going to be an object that has a value for the player team and the enemy team. And that value is going to be an ID of one of the combatants. So we're going to start with player 1 versus enemy 2. In fact, let's change this to be enemy 1. so we see a different pizza on screen. Now any combatant can check if it's the active one just by checking this value here. So we'll come over to combatant.js and make one more getter for this video. It's going to be isActive. And we're going to return this.battle.active combatants. And then we're going to check the team, and each combatant has a team on it. Remember, when we create the combatants, we pass in a team. So it's either going to be player or enemy. This.team equals this.id. Checking to make sure this value is my ID. And now in our update method of combatant.js, we can come find that. We can add in the part that adds that data attribute saying if this combatant is the active one or not. So we'll say this.HUD element set data attribute data active to be this.active. So whenever update runs, it'll run that active check, and then it'll toggle that value true or false. So let's see this in the DOM. When I reload here, you can see a different pizzas active up here because our CSS is kicking in now that we had before. So only combatants with data active true are going to show up. Everything else will still be there, but it's going to be invisible. So now we only see data for relevant combatants. Okay, let's start getting some pizzas on the screen. I'm going to close out of these, get back to the code. Now in combatant.js, when we create our elements here, right under where we create the HUD element, we're going to create a new element called pizza element. So this is just going to be this.pizza element is going to be a new element. This time it's going to be an image. And now I'll bring in some lines that further flesh out the image. For one, we're going to give it a class list name of pizza. So pizza class. We'll give it a source of the pizza, which again is defined in our pizzadex over here, like this right here. Alt tag with the name, of course, and then the team that this pizza belongs to. That's going to help us position it in the right spot. Now, when we initialize, we're already creating or appending a child of this HUD element. Let's do the same thing for our pizza element. So we'll change this to pizza. Starting the game up looks like this. So you can see the pizzas are working, but they're not positioned right, and we're showing too many. They're just kind of in the DOM. So let's add the CSS we need now. Back in combatant.css here, I'll go to the bottom of the file and bring in some styles for our pizzas. For one, our pizza, just like everything else, is going to be position absolute and transform scaled up by 2 to match the correct pixel ratio of everything else. We're also going to include one of those background images for the pizza shadow to give the pizza some depth. We set our team as a data attribute on the pizza so that we can position them differently. So the player pizza, again, will hug the bottom left here, while the enemy pizza will be towards like the top right. Now we see pizzas correctly on the screen, but there's still a little bit of a problem. You see how this pizza looks like a little darker and it doesn't match the veggie vibe? That's because we're actually showing both pizzas for both enemy combatants, where just like we did with the HUD scoreboard, we need to only show the pizza that's relevant right now. Back in our pizza CSS here, let's layer in a few more rules that say that basically the same thing that we had with the HUD. So if data active is false, we want opacity to be 0, and if data active is true, we want opacity to be 1. Let's go ahead and add this data active onto the pizzas. Back to combatant.js, in our update method, we're doing this kind of pattern for the HUD. Let's just do the same thing for the pizza too. So this.pizza element set attribute data active is going to use that same flag, is active. Let's add some clarity here. Now when we reload the scene, we see that the pizza is the correct one. The other one is still around, but it's invisible because it's not active right now. And now our basic battle scene is set up and ready to go. That's a good stopping point for this video. In our next video, we're going to start working on the basics of a turn cycle system, where the pizzas get to take turns choosing actions that affect the state of either themselves or the other pizza. This will involve getting text on the screen and then also some basic animations as well. If you're enjoying the series, please remember to hit the like button and subscribe for the whole thing. And if you've really gotten value out of the videos, there's a Ko-fi donation link in the description below where you can contribute to the development of more of these videos. If you have a game project you're working on, you should come into our game dev Discord and tell us about it. There's a link in the description below. Thank you so much. We'll see you in the next episode.